The James Webb Telescope is insane! The James Webb Space Telescope, JWST, is the largest and most powerful space observation telescope ever built. It is a next-generation observatory designed to help scientists answer some of the biggest questions about our universe and its origins. Hello guys, and welcome back to Tech World. We're here with another space-related video for you to enjoy and learn about. If you're a space enthusiast, you're probably familiar with the James Webb Telescope. Check out what we have to show you today, and stay with us till the end to find out the interesting news about this. Now let's look into today's video. What is this telescope? So guys, why is this Webb telescope so special? The James Webb Space Telescope is an infrared observatory, orbiting the Sun about 1 million miles from Earth to find the first galaxies that formed in the early universe, and to see stars forming planetary systems. You can say, then again, we already have Hubble with us. It's simple, because unlike the Hubble, which enters and exits Earth's shadow every 90 minutes, Webb will have an unobstructed view that will allow scientific operations to be conducted 24 hours a day, 7 days a week. The talk about how the $10 billion James Webb Space Telescope will probe the cosmos to uncover the history of the universe from the Big Bang to alien planet formation and beyond is quite intriguing. Don't you think so, guys? But it is said that the Webb will study the earliest moments of the universe, star formation, far-off exoplanets, and scientists even hope that it will help them understand dark matter. It would be nice to finally have an explanation of how this world really started. Common info. Here's a bit of information about Webb for you, just so you know the basics. Launch date December 25th, 2021, 12:20 UTC. Science targets: our solar system and beyond our solar system. Type: orbiter. Agency: NASA. Goals. Since we already know a couple of the goals of Webb, why not know some more? Search for the first galaxies or luminous objects formed after the Big Bang. Webb will conduct ultra-deep, near-infrared surveys of the universe, followed by low-resolution spectroscopy and mid-infrared photometry, the measuring of an astronomical object's electromagnetic radiation intensity. High-resolution, near-infrared spectroscopy will be required to investigate reionization, determine how galaxies evolved from their formation until now. Scientists are attempting to comprehend the formation of galaxies, their evolution, and the formation of elements heavier than hydrogen. The James Webb Space Telescope will contribute to answering these concerns while also providing a unique insight into merging galaxies. Webb will also allow astronomers to collect information about the many sorts of stars that existed in these extremely early galaxies. Observe the formation of stars from the first stages to the formation of planetary systems. To the right, the stages of solar system development are depicted as a protostar immersed in a gas cloud. Top left of the figure. An early star surrounded by tiny planetesimals that are starting to clump together, bottom left, and our current solar system. The specifics of how they evolve and recycle the heavy elements they manufacture into new generations of stars and planets must be discovered through observation and theory. Measure the physical and chemical properties of planetary systems, including our own solar system, and investigate the potential for life on those systems by observing our solar system, life, and the planetary systems more keenly. Features. Let's talk about the features of this infamous telescope. The James Webb Space Telescope has an expected mass of about half of the Hubble Space Telescopes, but its primary mirror, a 6.5 meter, 21-foot diameter, gold-coated beryllium reflector, will have a collecting area over 6 times as large, 25.4 meters squared, 273 square feet, using 18 hexagonal mirrors with 0.9 meters squared, 9.7 square feet, obscuration for the secondary support struts. The Integrated Science Instrument Module, ISIM, is a framework that provides electrical power, computing resources, cooling capability, as well as structural stability to the Webb telescope. It is made with bonded graphite epoxy composite attached to the underside of Webb's telescope structure. The ISIM holds the 4 science instruments and a guide camera. Since Webb is an infrared telescope, its focus will be on spectroscopy. Webb will mainly observe infrared light coming from faint and very distant objects. In L2, Webb will not experience the same temperature shift effect that can distort telescopes' ability to see the universe. According to NASA, Webb will act as an infrared detective, detecting invisible light for us and uncovering otherwise hidden regions of space. The telescope has a mirror that can extend 21 feet 4 inches, 6.5 meters. This huge length allows the mirror to collect more light from the objects it observes when the telescope is in space. The telescope includes instruments from the Canadian Space Agency and the European Space Agency. Are you ready to learn more about Webb? Wait till the very end so that you know all that you need to know about this amazing telescope. Amazing facts. Here we're going to let you in on some amazing facts about James Webb. Number 1. Look back in time with Webb. The James Webb Telescope will allow scientists to peer not just deeper into space, but also back in time. Astronomers hope to use the new telescope to examine the universe's very first stars and galaxies in order to unlock its mysteries. Number 2. James Webb's Golden Mirror. The new telescope has at least 100 times the power of the Hubble Space Telescope. Astronomers hope to obtain vistas of the universe like never before with its golden mirror. To have the best perspective of space, one must be in space. That is exactly what Webb will do. The Hubble mirror was 7.8 feet in diameter, whereas the James Webb Telescope's mirror is 21.3 feet in diameter, allowing it to collect 6 times more light than Hubble. Number 3. A better understanding of our universe's history. Hubble's photographs represent not just galaxy systems, but also a collection of the universe's history. Scientists were able to peer into galaxies that originated 400 million years after the Big Bang thanks to Hubble. The James Webb Space Telescope may be able to bridge the gap by displaying photos from 250 million years after the Big Bang, bringing us closer to the beginning of our universe. Aside from viewing galaxies, the new telescope will improve image detail by adding spiral arms, more light, and greater structure. Number 4. Understanding the dark ages of the cosmos. Before the first stars arose in the cosmos, the entire universe was virtually blanketed in a primordial gas of some type, giving rise to the term cosmic dark ages. Scientists believe that the first illumination from galaxies helped to clear the cosmic fog. But with the aid of the telescope, they aim to gain a better understanding of the fog. Number 5. Infrared lighting. While the Hubble telescope mostly gathers photographs in ultraviolet, visible light, James Webb will primarily capture images in infrared light, providing greater detail about the objects in those images than ever before. Astronomers may be able to peer into incredibly old galaxies using infrared photography due to a phenomenon known as redshifting, in which light is stretched as it comes and goes, leaving a red trail behind. Infrared will be able to see extremely ancient galaxies that are now being pushed further away from Earth and turning redder with infrared. That's how you go through time. Number 6. The telescope will deploy itself in space. Due to engineering obstacles encountered when creating the massive $10 billion James Webb Telescope, scientists determined it was better to fold the telescope inside a rocket, which will subsequently be sent into space far from Earth. The distance from Earth is significant since our planet is warm, which infrared sensors detect rapidly and which astronomers want to avoid. Number 7. The distance from Earth is huge. While Hubble was just 547 kilometers from Earth, the James Webb Telescope will be millions of kilometers away, about 4 times the distance between Earth and the Moon. If something went wrong, humans would be unable to service James Webb, as engineers were able to do with Hubble after discovering a problem with its mirror shortly after launch. Simply said, the James Webb Space Telescope will either function or not operate. And of course, we are certainly banking on the former to see all of the magnificence that exists in our cosmos. Recent updates. Earlier this week, the spacecraft overcame its most difficult challenge, the deployment of a sun shield, which JWST uses to deflect sunlight and keep its sensors cool. With JWST in its final shape, scientists will have to fiddle with the mirrors a little more to verify that they're aligned, as well as continue to calibrate its equipment before it can disclose the mysteries of the universe. The JWST will arrive at its final destination in outer space in roughly 2 weeks. We'll have to wait until the summer to see more of the first photographs from the JWST, but it'll be well worth the wait. So guys, that's all for today's amazing video about the information giant James Webb Telescope. So what do you think about it? Would it be able to help find the real origin of this world? Would it be able to help us guess the major future events? Do leave a comment below for us to see. Don't forget to like this video and click that subscribe button to get updates from our channel. Until we meet you in our next video, adios!